Good day, this is Teacher Riza. Our lesson for this episode is about logarithmic function, logarithmic equation, and logarithmic inequality. So here we're going to discuss logarithmic function, logarithmic equation, logarithmic inequality, laws of logarithm, basic properties of logarithm, how to expand logarithmic expression, and how to condense logarithmic expression. And our learning competency for this lesson is the learner distinguish logarithmic function, logarithmic equation, and logarithmic inequality. So first we're going to discuss the basic properties of logarithm. So let b and x be real numbers such that b is greater than 0 and b is not equal to 1. So first property is the logarithm of 1 to the base of b is equal to 0. Then second property of logarithm is the logarithm of b raised to x to the base of b is equal to x. Third property is b raised to log of x to the base of b is equal to x if x is greater than 0. Now, let's try to use the basic properties of logarithm to find the value of the following logarithmic expression. First, the logarithm of 1. That is, a common logarithm to the base of 10 means that is log of 1 to the base of 10, which is equal to 0. That is using property number 1 or the first property. That is, log of 1 to the base of b is equal to 0. The logarithm of 10 squared is equal to the logarithm of 10 squared to the base of 10, which is equal to 2. That is using the second property of logarithm, that is log of b raised to x to the base of b is equal to x. Next example is log of 256 to the base of 2. We can also write 256 to the base of 2, which is equal to 2 to the 8th power. So that will become now log of 2 to the 8th power to the base of 2. That is 2 raised to log of 8 to the base of 2 is equal to 8. That is using the third property of logarithm, that is b raised to log of x to the base of b is also equal to x. The next example, the natural logarithm of e cube is equal to log of e cube to the base of e is equal to 3. That is using the second property, that of log of b raised to x to the base of b is equal to x. Next example, the logarithm of 1 over 49 to the base of 7 is equal to the logarithm of 7 raised to negative 2, that is 1 over 49 is the same as 7 raised to negative 2. So that will be log of 7 raised to negative 2 to the base of 7 is equal to negative 2. That is using the second property of logarithm, that is log of b raised to x to the base of b is equal to x. Next example, 6 raised to log of 3 to the base of 6 is equal to 3. That is using the third property of logarithm, that is b raised to log of x to the base of b is equal to x. So what is a logarithmic equation? It is an equation involving logarithms. An example of this is the logarithm of 2 to the base of x is equal to 4. What about logarithmic inequality? It is an inequality involving logarithms. An example of this is the natural logarithm of x squared is greater than natural logarithm of x raised to 2. What about logarithmic function? It is a function of the form f of x is equal to log of x to the base of b, wherein b is greater than 0, but b is not equal to 1. An example of this is g of x is equal to the logarithm of x to the base of 3. Now, let's try to identify whether the given is a logarithmic function, equation, or inequality. The logarithm of 2 to the base of x is equal to 1. So that is a logarithmic equation. Number 2, the logarithm of x to the base of 3 is equal to y. So this is a logarithmic function. Number 3, the logarithm of 125 to the base of 1 over 5 is equal to x is a logarithmic equation. The logarithm of 125 to the base of b is less than 1 is a logarithmic inequality. And h of x is equal to the logarithm of x to the base of 0.25 is a logarithmic function. So what are the laws of logarithm? Let b is greater than 0 and b is not equal to 1, wherein n is an element of real number, and m is greater than 0, and n is greater than 0, then we have the product law. The logarithm of m times n to the base of b means we're going to add the logarithm of m to the base of b plus the logarithm of n to the base of b. So that's a product law. Then we have the quotient law. The logarithm of m divided by n, or m over n to the base of b, means we're going to subtract the two logarithm, that is the logarithm of m to the base of b minus the logarithm of n to the base of b, the quotient law. Then we have the power law. The logarithm of u raised to n to the base of b means we're going to multiply the exponent n to the given logarithm, so that's n times the logarithm of u to the base of b, which is the power law. For example, we're going to use the rules of logarithm to expand each expression in terms of the logarithms of the factors. Assume each factor is positive. For example, we have the logarithm of rs cubed. So that means that is the product of the logarithm. We're going to add the two logarithms, that is a log of r plus a log of s cubed, that is using the product law. But since we have an exponent for s, so we're going to multiply 3 to the logarithm of s, that is log of r, plus 3 times log of s, that is using the power law. The next, the logarithm of 4 over y raised to the 5th power to the base of 2. Since we have an exponent of 5, that means we're going to multiply 5 to the logarithm of 4 over y to the base of 2, that is using the power law. Since we have the quotient of 4 and y, means we're going to subtract the logarithms, that's 5 log of 4 to the base of 2 minus log of y to the base of 2, that is using the quotient law. And log of 4 to the base of 2 is equal to 2. So we have now 5 times 2 minus log of y to the base of 2, which is equal to 5 times 2 is 10 minus 5 times log of y to the base of 2. Then for exercise 2, use the laws of logarithm to condense the expression as single logarithm. That is 2 log of x plus log of y. This is the sum of two logarithms, so it means we're going to multiply. But since we have 2, so first we're going to place 2 as exponent of x, so that's log of x squared times y. That is using the power law and the product law. Next, we have 7 log of a to the base of 3 minus 7 log of b to the base of 3. Since we have 7, so that means this is an exponent of log of a to the base of 3 minus log of b to the base of 3 raised to 7, that is using the power law. Since this is the difference of two logarithms, That means this is the quotient. Using quotient law, that is log of A over B to the base of 3 is equal to 7 raised to 7 is using the quotient law. Now, how to change of base formula? Where A and B and X are positive real numbers, with A is not equal to 1 and B is not equal also to 1. For logarithm of X to the base of B, that is equal to log of X to the base of A over log of B to the base of A. Then, use the change of base formula to rewrite the following logarithmic expression to the indicated base. For example, log of 8 to the base of 4, that is equal to log of 8 to the base of 2 over log of 4 to the base of 2. 4 and 8 is both in base 2, which is equal to 3 over 2. Then the logarithm of 2 to the base of 3, that is the natural logarithm of 2 over the natural logarithm of 3. Let's find now the value of x of the following logarithmic equation. For example, we have log of 8 to the base of x is equal to 3. So what is the value of x? In exponential form, that is x cubed is equal to 8. So therefore, the base is 2 because 2 cubed is equal to 8. So x is equal to 2. For logarithm of 1 over 27 to the base of 3 is equal to x. So that is an exponential form, 3 raised to x equal to 1 over 27. So what is the exponent of 3 to become 1 over 27? So that's 3 raised to negative 3 is equal to 1 over 27. So therefore, x is equal to negative 3. Then we have log of x to the base of 5 is equal to 0. In exponential form, that is 5 raised to 0 is equal to x. So therefore, x is equal to 1. That is 5 raised to 0 is equal to 1. That is logarithm of 1 to the base of b is also equal to 0. For your activity, entitled log the appropriate log, you're going to determine whether the following is a logarithmic equation, inequality, function, or neither. Just write logarithmic equation, logarithmic inequality, or logarithmic function from number 1 to 10. And then for activity 2, entitled log the log value, you're going to use the basic properties of logarithm to find the value of x of the following logarithms, that is from 1 to 10. So again, before we end, let me share this inspirational quotation. Do what is right in the right way and the right time. So again, this is Teacher Riza saying thank you. Please don't forget to like and subscribe. Have a nice day.